You're listening to Setting Course, an ABS podcast. Join us as we navigate the latest trends, developments, and challenges facing the rapidly evolving maritime and offshore industries. Catch every episode at www.eagle.org and podcast platforms everywhere. Hello, and welcome to today's show. I'm John Snyder, managing editor of Riviera Maritime Media, and I'll be your host. Joining me today on Setting Course, an ABS podcast, to discuss carbon capture, utilization, and storage is Joe Rousseau. Joe is the ABS Director of Offshore Technology. Joe, welcome to the show.
Thanks very much. Appreciate the invitation, and I'm happy to be here.
Now, Joe, before we jump into the discussion on carbon capture, tell our listeners about yourself. How did you get your start in the marine industry?
Well, I grew up in a small city on the east coast of Canada, St. John's, Newfoundland, and I just loved boats in the sea and discovered that there was this career path called naval architecture. And so I did a degree at university, and I've been working at shipyards and consulting firms and with ABS now for a good 30 years.
Great. Well, thank you for sharing that. Sounds like a great experience. Let's talk about carbon capture and storage. Now, it's been around and used in the oil and gas sector for decades and is now being viewed as an important bridging technology in the energy transition as shipping awaits new low and zero carbon fuels. Where are we in the development of onboard carbon capture?
Well, it's still early days in terms of getting anything into the ships that are out and sailing. There's certainly a lot of research and development work going on. A lot of it has been focused in a couple of major areas in the post-combustion, taking the engine exhaust and cleaning it up type of area. The first has been kind of adapting what's been used on land and in some of the power generation and refining and other industries to capture carbon and taking those systems which absorb CO2 into a chemical, and then you're able to strip it out and store it. And so we're adapting those technologies to a smaller platform that's on board a ship. And there are some other exciting projects as well where people are working on different technologies rather than the chemical absorption. And they're hoping that they can give you some maybe better efficiencies, maybe better storage means and that sort of thing. But it's still very much a developing situation. There are not a lot of installed systems on board in the marine fleet at the moment.
Now, you mentioned getting that technology, the onboard carbon capture, into the confined spaces of a ship. Can you talk about the challenges of scaling this technology for shipboard use?
Sure. Obviously, you don't have the same available real estate that you have when you're locating a carbon capture facility next to a refinery, for example, or a power plant. You do have something that's going to be of smaller space, and you have to worry about weight and center of gravity because it is still a ship, and so you have to think about stability. You also have to be able to have the associated systems that go with it. If you're using water sprays and other utility systems, certainly electrical power is something that you have to think about. And to be honest, the systems themselves use more energy in order to do what they need to do. So you're actually going to burn a little more fuel in order to generate the power that you need to run these systems. But the end product is that you're able to absorb a certain amount of the carbon dioxide that's in the exhaust stream. It can be anywhere from 30% of the exhaust right up to to close to 100%. The thing is, the more you absorb, the more energy you have to put into it, the more space you need to store. And one unfortunate thing about liquid carbon dioxide, if that's what you're producing, is that it's going to generate 3 times the weight of the fuel that you burn. So when you think about the storage space and capacity, if you try to capture 100%, you're going to have a lot of liquid CO2 that you have to store on board the vessel. Whereas if you capture smaller amounts, you have to store smaller amounts. So it all goes into it.
Right. Now, you mentioned, of course, storing that CO2 on board, and of course one of the challenges as well is where do you drop it off? Where are we in that value chain of supporting CO2?
Yeah, that's one of the big chicken and egg moments that we have right now is that we can do the capture, and put it into a liquid form, or some systems will develop solids, whether it's calcium carbonate or different forms of carbon, or even reacting it into other chemicals or acids that you can monetize and sell rather than, using as a waste product to be stored somewhere. But at the current time, there aren't a lot of ports where you can pull in and unload, liquid CO2 or solids without having some sort of contract and infrastructure in place to do that. There are some who are trying to do certain things like being able to have modularized offtake. So you're working with containers that you can load and unload with the product, and that is a promising solution for some areas. But it's going to be a while, and you may see it in green corridors first, where a given endpoint or a given pair of endpoints implements that along with the other things that they're doing to make a more environmentally friendly green corridor type of arrangement, where you have reduced emissions, reduced energy, and this may be part of it that goes into it.
But Joe, you mentioned chemical absorption, and what types of technology are you seeing being piloted and deployed for carbon capture?
Yeah, sure. That's a good question. We see, of course, the amine absorption. Amine is a chemical that can be used and has been used quite a bit in onshore applications, where the carbon dioxide can be absorbed into this chemical, and then the chemical can be regenerated so that you remove the carbon dioxide from it and can reuse that amine again in a cycle. Eventually, it wears out, and you do have to replace the amine, but it's pretty much a well-documented and pretty well technically established way to absorb the CO2, and then you can store the regenerated CO2 in a liquid form generally. But there are other means out there, things like solid adsorption, where you are capturing the CO2 onto the surface of, like small nodules or things like that. You can also have calcium looping, where you're using a chemical like calcium oxide that captures the CO2, and then you get a solid output rather than liquid. You get calcium carbonate or limestone. And there are other systems like membrane systems as well. There are various chemicals that you can use. None of these are really at the technology readiness level of an amine system, but we're seeing a lot of them used in pilots, and we see that there's great potential for them as they're working out in the testing, the efficiencies and the energy requirements and things like that. And so there's many different ways that you could possibly go right now.
Right, and could you highlight, I guess, any projects that ABS is currently working on in carbon capture?
Sure. I mean, we've done a fair number of approvals in principle of vessel designs that have come out of major shipyards in Asia, for example. We've got a number that we've worked on with both the amine absorption and other types of processes. We've been working with vendors. There are a number of them that have been piloting things on board. So we've worked with some companies at the approval in principle level or the new technology qualification level for some of these newer, non-amine type of systems, and we've gone through and put some of them on board vessels as well. For a pilot type project where it's not a full installation, that's going to be soaking up 30 to 90% of the CO2. It's a small, installation that will allow you to absorb, something like a ton of CO2 a day or something like that, just to be able to prove the technology, see if there are any bugs that need to be worked out in things, and they're very useful to do an actual real world test bed. Particularly for some of these newer systems where we just don't have the long service history or relatively long service history comparatively of the amine systems.
Joe, do you see an ideal vessel type for the deployment of carbon capture technology?
I mean, it's really applicable across a very wide range of vessels, as long as they're of a significant size. You can't put a carbon capture system on a very small vessel. There just isn't the space and the power available to do that sort of thing. But when you look at something like an LNG carrier, for example, the liquefied natural gas folks are already used to dealing with chemicals and with heat transfer and liquefaction. So there's been a lot of interest in potentially putting these onboard LNG vessels, since they can use the LNG as fuel, and then they can use carbon capture in order to reduce the emissions. But we've also seen it on other large vessel types. Some interest in some large tankers and container ships. Certainly, we'll see how it works out. A lot of it may be tied to what regulatory schemes are available for folks to use, to be able to take advantage of the reduction in emissions that you could get from a carbon capture situation.
I know you don't have a crystal ball, of course, but what's your feeling as far as when these technologies will be commercialized on a broader basis?
Well, we're still in the early days right now. I think it's going to be a few more years. It's not long term. We're not talking 30 or 40 years, but probably within the next 5 to 10, you'll see a lot more installations, both at the pilot level, but also at the commercial level. The issue, of course, as we talked about earlier, is the infrastructure. And the situation that we have right now from a regulatory side is that you're not really getting credit for carbon capture yet. That's something that has been under active discussion at the International Maritime Organization. They're set to discuss it more. But the whole discussion of where that fits into the carbon intensity indicators and the design indexes, as well as in the whole well to wake versus tank to wake discussion. There's certainly a lot of people trying to work out how that's going to be reflected in the marine industry. But anywhere that you have something like a carbon tax, for example, this is going to be attractive because it enables you to get some sort of rebate or just pay less tax. So you may see that in certain regional areas around the world, like Europe, for example, before you see it in other areas. The problem is that you're essentially dealing with a waste product. Paying for that is not something that you can easily monetize unless there's some sort of incentive. And certainly a lot of companies have these incentives, whether it's from their financiers or from their regulators or that sort of thing. But we're still waiting for that rather complicated landscape to play out, because there's still a lot of money that's going to have to be spent in terms of building up these infrastructures and making sure that these regulations and supply chains are in place.
Right. So clearly, as you highlighted, government policy has a role to play in the deployment of this technology. And you mentioned, of course, commercialization. Could the captured CO2 be used, say, for example, to create synthetic fuels as well?
Absolutely. That is one path forward, is the idea that you could take captured CO2 and then use it with some sort of green power generated hydrogen or with nitrogen to create ammonia fuels or methanol fuels. And then from the methanol, you could recapture the carbon and then reuse it again to make more methanol, for example. So there is a possibility to do these type of things. The issue is going to be the scale and building up again of this infrastructure. I mean, to date, we've used CO2 as a product for things like enhanced recovery, where you inject it into a well and it helps you recover more oil and gas. We also have it in the food and beverage industry. I mean, your soft drinks will have carbon dioxide in them, food grade carbon dioxide. But the amount and scale of carbon that we're talking about from some of these capture efforts is going to be vastly larger, on the order of 10 to 100 or even more times what we're currently capturing and using. So we have to figure out something to do with this. Regenerating it into fuels is one way to do it. Again, as I said, making it into other products is a possibility as well. But it's something that is being wrestled with, because it's a challenge from the financial standpoint, to make this all work.
Now, do you see carbon capture and storage as a critical technology for helping shipping meet its net zero GHG target by 2050 or thereabouts?
Absolutely, it's important. I mean, we've seen a lot of interest in it over the past couple of years, and interest just seems to be growing, and more systems are being worked on, more design has been done on these type of vessels that have something on board. So that there's a lot of work into it. It's something that will play a role, especially as we wait for, again, large-scale alternative fuel production. They have their own infrastructure issues, of generating methanols or ammonias or anything like that. And for existing ship retrofits, it may be more easy to put on a retrofit modular carbon capture system that is able to absorb, say, 30% of your CO2. But it's a lot harder to replace an engine and fuel system on an existing ship. So we may see that it is something that's of use to the existing fleet in making sure that they can get the most out of the vessels that they have now, and move into the future. We also have, of course, that we haven't talked about very much is just the transportation networks, and what role shipping will play there, because shipping emissions are around 2.5 to 3% of the overall emissions worldwide. There's going to be a lot more capture that's happening on power plants and cement plants and things like that onshore. And some of that may have to be shipped to other locations, depending on on where the sequestration takes place, where they're injecting it into the ground, or where it's being monetized into a different commodity, for example. So the trade of liquid CO2 carriers may be another aspect of this whole industry that we have to think about. The pipelines and port terminals as well that go into all of that. So it's not just the onboard capture that we need to think about. It's the whole ecosystem, the whole economy around CO2 that's probably going to develop. And that's without even mentioning any of the direct air capture technologies where, they're not tied to a specific exhaust stream. They're just pulling CO2 out of the air somewhere. So there can be a whole industry that builds up around this, and it involves shipping in many aspects. And that includes right to the offshore platforms that may be sequestering it in the ground. They are also part of the marine industry, as they operate in the offshore environment.
So clearly, lots of opportunity for shipping, and possibly the reuse of depleted wells and existing infrastructure as well.
Yes, exactly. I mean, there's a lot of very good possibilities out there when it comes to either depleted oil wells, or also saline aquifers offshore are interesting as well. These are pretty good for injecting CO2 into, and the idea with offshore injection is that you can, if you're dealing with aquifers, of course, and they're already saline and they're offshore, you don't have to worry about the impact of potential nearby drinking water sources the same way that you do with if you want to inject it on land, for example. You won't see a lot of it in very deep water because of the very high pressures that you get, and that's not particularly conducive to storing CO2, just because of the well profiles and things like that. Not an area we get into a lot. We tend to focus on the safety of the offshore platforms and the injection lines and everything down to the seabed. But certainly there's a lot of potential in the onshore and nearshore, and getting into some of the offshore as well, depending on depth and that sort of thing. And there are various operators and oil companies and other institutions that are looking at this, looking at where is it appropriate and where could they put the CO2, when it comes down to an area where can they store it, and where can they leave it and have a good chance that it stays in the ground.
Now, Joe, with just a few minutes left in our podcast, I was wondering if you had any final thoughts to share with our listeners.
Yes, I mean, it's a growing and very interesting area. Certainly, there's new technologies, and we can handle them with our existing procedures for qualifying new technologies and approving new vessel designs in principle. We've already published some classification rules. We're waiting on the International Maritime Organization and various government entities to decide what they want to do from a policy standpoint, and then the entire industrial infrastructure of where all that goes, in ports and pipelines and where this commodity is going to be moved around the world. It's early days, but as we've seen with many industries that we've engaged with in offshore and in some of the data environments that we deal with now, things can happen very quickly when people put their minds to them. And so we're pretty excited about the things that can happen and the steps that we can take, and the advances that the whole industry can make over the next few years to make this a reality and see that we can help the environment and reduce these emissions and do it in a safe way.
Thank you, Joe. Thanks for joining me today.
Hey, no problem. I appreciate it.
Thank you for joining us today on Setting Course, an ABS podcast. If you're interested in learning more about today's topic or listening to more episodes, visit www.eagle.org.